All right. One more video about color possibilities. I hinted on this in the previous video, but with narrowband, particularly if you have three of them, then you have a number of color options. Let's start with natural. So this is the image I just made in the previous video, and I'm going to set the 03 back to the 03 color, which I don't like how it looks, but for the H alpha layer, we have the bomber color. For the 03 layer, which is under the luminance layer, we have the 03 color. And for S2, we have red. And those are the natural colors of the bomber sequence, the 03 doublet, and the S2 doublet. Okay, so that's one thing you can do. Often, astrophotographers will do something. Well, actually, let's change this image. I'm going to move everything above the luminance layer. Not really care about the noise problems, just to demonstrate the colors here. And the S2, I'm going to set this back to lighten. And so now, since I moved that stuff above the luminance layer, we have noise issues. I'm going to bring these three kind of into alignment, though. Let's see here. With let's make the S2 go up to 90%. Yeah, let's make the 03 go up to 90%. And the H alpha, it's already at 90%. So I'm not trying to be pretty here. I'm just trying to show you the different color possibilities. So all three are colored naturally at the moment. Now, what people will often do when making narrowband images, well, a couple things. One thing you can do is if everything's above the luminance layer and you have good signal to noise, you can make a color combination, and then you can adjust your stars separately. Like here's the stellar layer, the luminance layer, which includes the R, V, and B beneath it. I can tamp the stars down. There we go, 99. And see how the stars got fainter, or 99.9. There's a point where right there, I tamped it down too far. And so now I'm just seeing the stars that are in the narrowband layers. I've essentially turned off the LRGB. So I'll bring this up, but that's one thing that you can do is you can bring the stars down and really focus on the gas if you want to. Maybe I'll leave it there just for this demo. Okay, and so back to the gas. We have natural colors, red for S2, bomber for the hydrogen, and the 03 color for the oxygen. Now, most of the time, people don't use natural colors. We created these primarily for the Afterglow environment. Often what they'll do are different combinations of red, green, and blue. So the first combination I'll show you is called the SHO palette. That's the order. The longest wavelength is the S, the sulfur. So people color it red. Let's do that. It's already red. The next longest is hydrogen, H alpha, which is also in the red part of the spectrum. It's just a little bit greenward. And so people just color it straight up green. It's not truly emitting green, but you can do that. And then your oxygen layer, you bump that up to blue. It's the bluest of the three. Sulfur's the reddest of the three. And so here we have a combination like that. And then you can go in and you can tweak. Like if you want more of the sulfur, I put on the sulfur controls here, and I can boost that layer as I see fit. Again, with this data, it's really noisy. So, I wouldn't recommend, let's go to like 70. I'll set it back to 90. You can see little hints of red. The red layer, really, it's just kind of accentuating the outlines. We see a little bit of it coming through here. So this is the SHO color palette. Another one is HSO. In this case, you color the hydrogen red and the sulfur green. And O is last in HSO, so it's again blue. So we have something like this. Green really, if you have any noise in your green layer, it really stands out. Green just kind of screams to the human eye. I don't know why, but since our sulfur layer is now green and it's the noisiest layer, you really see the noise. But at the same time, it really does a nice job with the outlines. So, you could play with this. You can adjust it. You could, for example, return this under the luminance layer. And, it tamps down the noise. I'll put it back up for the color demonstration though. Okay, what else do you have? Often your sulfur layer is just too bad to use, so we can just turn it off here. And people will often use what's called the HOO palette. So here you color the hydrogen red, and it is, and the oxygen is pumped into both the green and the blue channels. And so we have a color here, blue-green. It's equal parts green and blue. And so there you have the HOO palette. Again, the oxygen's a little noisy. You're going to want to tweak this and play all the games to hide the noise, but that's another palette that you can work with. And the last one on my list to share, we created the Balmer color, the true color of hydrogen. We created the O3 color. Let's go back to that, actually. So hydrogen, we'll color this Balmer. Oxygen, let's color it the O3 again. I'll turn on the sulfur again, and we'll color that one red. Okay. Just check, make sure that's right. Red. Yep, so we're back into natural color land. But since sulfur and hydrogen are both kind of red, we created another color that's the counterpart of the Balmer color and the O3 color. Like on the colored wheel, what color is across from these two on the colored wheel? It's a color that we call harmony. So I can load in harmony here. And so this, although I find this god-awful to look at, that's a combination of three colors that are supposed to go together. You may need to change the order of them to make this look good. Let's try that. Let's make like an SHO palette, red, green, blue, but instead of red, green, blue, we'll use harmony, O3, OI, and let's see, instead of red, we'll use Balmer. Instead of green, we'll use OI, and instead of blue, we'll use harmony. So hydrogen, let's see, the oxygen, that one becomes harmony. The hydrogen, if it's an SHO, this would actually get the O3. And the S2 would get the Balmer color. So here we've reordered them. This is SHO, but instead of using red, green, blue, we're using Balmer, OI, and harmony. Or if you want to do an HSO, but using these colors, we change this one to the OI and this one to Balmer. So again, a zillion things that you can do. You have the red, green, blue to work with. You have the Balmer O3 red, which is natural, and you have Balmer O3 harmony, which is a color balance. And you can assign them whichever way you want. But then you have to deal with the noise And I gave you tips of the trade in the previous video, moving things below the luminance layer, and if necessary, switching from lighten to screen. And lastly, just remind you of the stars. If I put this on the luminance layer, that's another thing that you can adjust. Like, let's bring the stars back up. The default 97.5. See how it brightens that layer. And so once you get the gas the way you want, you can adjust the stars up and down. And also, if you don't know your extinction, that's another parameter. So I can go to photometric color calibration, and I can change this. Let's take it out completely, just as an example. And that just changed the red, green, blue combinations of the stars. See how the stars got redder, but it didn't change the gas. Now I'll put it back in. 0.782, I think it was. And this corrects the stellar colors. But again, since we're using lighten for the gas layers, it stayed put. Okay. That's the second video. I'll shoot another one on the infrared layers in a little bit.